Today we're going to look at question 34 in our study guide. Okay, so 34 reads, the length of a rectangle is 5 feet less than its width. If the area of the rectangle is 84 square feet, find its dimensions. Okay, so we're trying to figure out the length and the width of this rectangle. So the first thing I'm going to do, we're going to draw a rectangle. All right, and we have to see what they gave us. So they're saying that the area of this rectangle is 84. So we're going to put inside 84. And we know that the area equals 84. And then we have to think about how do we find the area of a rectangle? Okay, and we know if it's a rectangle, it has to be the length times its width. And we know that has to equal 84. Alright, so now let's talk about the first sentence here. The length of the rectangle is 5 feet less than its width. Okay, so this is where you have to use the word variables. Okay, so remember, we don't know what the length or the width is. So we're just going to label the width as x. Okay, and since we don't know the width, they're telling us that the length of this rectangle is 5 feet less than whatever the width is. So we're going to say that this has to be x minus 5. So I can write that out here. So we're saying we're going to let our x be our width. And whatever our length is, it has to be 5 less than that. Okay, so our length is x minus 5. And now we're just going to plug that in. We know what our width is, so we know that has to be x. And we're multiplying that with x minus 5. And we figured out that the area, they give us that the area has to be 84. And now that we have an equation, we can solve it. Okay, so with this x, I'm going to distribute it to both the 5 and the x. So this becomes x squared minus 5x equals 84. Now you could use completing the square, but since we're going to divide by -5, we're going to get a decimal. So what I'm going to do here is I'm actually going to bring the 84 back on this side. So we have x squared minus 5x. I'm going to subtract 84 from both sides equals 0. Now this gives me an easier quadratic because now I can say what multiplies to -84 and will add to -5. So take a second to think about that. Pause the video, see if you can figure out on your own. Alright, so that is actually going to give us x and -84, and we'll add to -5. Those factors would have to be -12 and +7. Now that we have two solutions here, we can just set them both equal to 0. So we have x minus 12 and x plus 7 equals 0. And we're going to solve for each x value. So we have x equals 12 and x equals -7. Now, since we're talking about a real-world problem, we have to remember that length can't be negative, or width can't be negative, okay? So our answer can't be -7 because there's no such thing as a negative width, okay? So our only answer in this case has to be x equals 12. So our width is 12. Now how are we going to find the length? Well, we know x is 12, so I can replace this x with a 12 minus 5, and this will be our length. So simplifying that, we know our length has to be 7. Okay, so going through our problem, we had to figure out, how can we figure out if they're giving us the area of 84, and we know the area is length times width, we had to write an equation that will help us solve for what each side is. So we said that since our width is x, we're going to label that as x, our length has to be x minus 5, because in our problem it says it's 5 feet less than whatever the width is. Okay. From there we were able to plug in our x and our x minus 5 and solve from there. We got a nice quadratic, and then we were able to solve for both. But we have to remember that a length or width cannot be negative, so we have to go with the positive solution, and we plug it into both of our equations that we figured out, and we get our answer. So our width is 12 and our length is 7. All right. All right, so let's take a look at 37, our favorite problems, projectile motions. Okay, so with projectile motion problems, you have to list out what they give you. Okay, so let's read the problem. So Natalie found a tennis ball outside a tennis court. She picked up the ball and threw it over the fence into the court. The path of the ball can be represented by the equation h equals negative 16t squared plus 18t plus 5. They want us to find the maximum height of the ball and how long did it take to reach the ground. So the first thing I'm going to do is I'm going to draw a picture of what's happening. So I'm going to draw this, okay? Okay, so Natalie is throwing her tennis ball over some sort of fence. Okay, so there's our fence, and here's Natalie throwing her tennis ball, and we know eventually it's going to land back on the ground. Okay? So we have to think about what's happening here. So I labeled a y and an x, but what's going to happen? Okay, so we're going to say our x is going to be our time. How long did it take for it to reach that maximum height or hit the ground? And then our y-axis is going to be the height of every instant that ball is in the air. Okay. Now remember, the ball didn't start on the ground; it started in Natalie's hand, so it has an initial height of however tall Natalie is. Okay. So then she's throwing her ball, and it's going to reach some maximum height. So we say our maximum height is here. Okay. And if you remember, when we talk about parabolas or in these quadratics, when it forms this U shape, our max height or our minimum height is also called the vertex. So this vertex is going to be our maximum height in this scenario, okay, not our minimum height because the ball is going up in the air, okay? And then we know at some point it's going to hit the ground. So looking at part A, we have to find the maximum height, or we need to find the vertex of this tennis ball, okay? Now if you remember, in order to find the vertex, you also have to remember that there's some sort of axis of symmetry here on both sides of our parabola, okay? So whatever's here is going to be is creating a similar side on this side and this side because it's forming that U shape. Okay, so with that vertex, we're first going to find the axis of symmetry. So if you remember, axis of symmetry is x equals negative b over 2a. But we just talked about that our x isn't actually an x this time, it's time. So I'm going to change this x to a t equals negative b over 2a. Okay? So if we look at our equation here, we have the height equals negative 16t squared plus 18t plus 5. And now if you remember, this is a quadratic, so we can go through and we can label our a term, our b term, and our c term. And then we're just going to plug in what we already know. So our b term is 18. So remember, this formula calls for a minus sign, so it's going to simplify to minus 18 over 2a. So we have a 2, and the a is negative 16. And now I'm just going to plug this in my calculator, remembering that this is a negative and this is a negative 16, and that is going to simplify to 0.56 or 56 hundredths. Okay. Now we have to think about, this is a time, so we need to label this. So we have to think about how long can a ball really last in the air. We know it can't last in the air for minutes or hours, so we're going to say this is 56 hundredths seconds. Okay. So it's important now that we're talking about real world problems, you have to think about what's going to happen in this situation. Okay, so we know the ball is not going to be in the air for minutes or for hours. Okay, so we're going to label this as seconds. We're trying to find our vertex. Okay, so we have an x value. So remember, that vertex is some sort of x and y value. Okay, but we just found that the x is going to be time, so that means we have to find our y value, the height. Well, we have an equation for height. So now that we know t, we can take this 0.56 and plug it in. So our height is negative 16, plugging in our new t. Okay, so I hope you guys have the calculator handy, so go ahead and plug this in. Remember, this is 0.56 squared, and it's 18 times 0.56, and you should come up with an answer of 10.06. Okay, and then now, once again, we have to think about our label, and we're going to label this as feet. Okay, 10.06 feet. Okay, so recapping, in order to find the maximum height of this tennis ball, this is asking us to find the vertex of this problem, okay, but not just the time. It's asking us to find the height of that problem. So we have to find our x and y, but we're using that x, we're able to find our y, but in this case, y is our height. Okay, so let's look at part B here. So how long will it take to reach the ground? Okay, so let's give ourselves some space here. Okay, so using our picture, we have to think about how long will it take to reach the ground. Well, what happens when the ball is at the ground? Our height has a value of 0. So same thing. Now that we know that our height equals 0, and we're trying to find time, because how long will it take? That's a unit of time. So we can rewrite our equation as negative 16t squared plus 18t plus 5. And we're going to replace that h with a 0 now. Now, looking at this quadratic, you could use the slip and slide method, or in this case, I'm going to use the quadratic formula as review for our class. Okay. So now we're trying to find time. So we're going to say t equals, and I'm going to rewrite our quadratic formula here. So we have negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. And if you remember from last video, we talked about this b squared minus 4ac. That is called the discriminant as well. Okay, so we already have our equation here. We already talked about what our a, b, and c term is, so we're just plugging in now. So it's going to simplify to negative 18 plus or minus the square root of 18 squared minus 4 times negative 16 times 5 all over 2 times negative 16. So we're going to solve what's under the discriminant first. So we're going to do 18 squared first. That's going to give us 324. Okay, simplifying this in our calculator, this is going to simplify to plus 320. And then that's going to give us 644. Okay, so if I rewrite our equation now, we have negative 18 plus or minus the square root of 644 times 2 times negative 16 is going to give us negative 32. Okay, now we have to solve this. Okay, so we can't leave our answer like this because we're looking for a specific time. Okay, so we're going to put in our calculator whatever the square root of 644 is. So that's going to give us negative 18 plus or minus the square root of 25.38. Okay, so I hope you have a calculator handy. These are some tricky problems here. All over negative 32. And now we're going to have to solve. Made a mistake here. So since we've already used the square root, we're going to remove our square root now. Okay, because we just simplified this. We took the square root of 644. Okay, so now we have to solve for our two scenarios. We have negative 18 plus 25.38 and negative 18 minus 25.38. So we're going to do both separately here. So we're going to have negative 18 plus 25.38 over negative 32. Okay, and if we put this in our calculator, this will simplify to negative 0.23. And then if we do our second equation, we have negative 18 minus 25.38 all over negative 32. And putting this in our calculator, this will simplify to 1.36. So we have two answers here, okay? And we have to think about, can these two answers be possible? Well, the ball is only going to reach the ground once, okay? Because Natalie threw the ball. So we know when it reaches the ground, we can only have one answer. It's not going to hit the ground more than once, okay? Now, if you look at this answer, it's negative. We have to think about it. Can time be negative? Is she going backwards in time? No, okay? So it cannot be negative 0.23. That means our final answer has to be 1.36. And we just talked about when we were dealing with our units that this is going to be seconds. So our final answer is 1.36 seconds. Okay. So we were able to take that since they were telling us how long will it take to reach the ground. Well, we know the ground, the height has to be 0. We were able to set our quadratic equal to 0. Using the quadratic formula, we were able to find our answer of 1.36 seconds.